are the various models with respect to LCM? Model number 1. Model number 1, yesterday we discussed. There is a number which is divided by multiple numbers. Multiple numbers, let me call it as P, Q and R. In all the cases, positive remainder will be same. This is the case which we discussed. Positive reminders will be same. X. A number is divided by multiple numbers P, Q and R. When a number is divided by P, remainder is X. When a number is divided by Q, remainder is X. When a number is divided by R, remainder is X. Yesterday we discussed, suppose if there is a number is divided by 3, divided by 4, divided by 5. In all the cases, positive remainder will be 1. In all the cases, positive remainder will be 1. Yesterday we discussed, I will repeat this key point. A number when divided by 3, remainder 1, number when divided by 5. Number is getting divided. Let the number be n. Number is getting divided by 3. Quotient we don't know. Let me call it as A1. Remainder it is 1. Dividend equivalent to divisor into quotient plus remainder. 3A1 plus 1. Similarly, number is further divided by 4. We do not know the quotient A2. Remainder it is 1. Dividend equivalent to divisor into quotient plus remainder. Similarly, a number is divided by 5. We do not know the quotient A3. Remainder it is 1. Dividend equivalent to divisor into quotient plus remainder. Now if you observe, number is divided by 3, remainder is 1. Number is divided by 4, remainder 1. Number is divided by 5, remainder 1. Now if you see, n minus 1 is equivalent to 3A1. n minus 1 is equivalent to 4A2. n minus 1 is equivalent to 5A3. If you observe closely, right hand side, it is divisible by 3. So n minus 1 should be divisible by 3. Right hand side, it is divisible by 4. Left hand side also should be divisible by 4. Right hand side, it is divisible by 5. Left hand side also it should be divisible by 5. So n minus 1 should be divisible by 3, 4 and 5. What is the number which is divisible by 3, 4 and 5, which can be written as LCM of 3, 4 and 5. LCM of 3, 4 and 5. It can be multiples of LCM of 3, 4 and 5. 3, 4 and 5. It will be the lowest number will be 60. 60 multiples all are divisible by 3, 4 and 5. So n can be written as LCM of 3, 4, 5 into k plus 1. 3, 4, 5 into k plus 1. I hope it is clear. When a number is divided by 3, positive remainder 1. Number is divided by 4, positive remainder 1. Number is divided by 5, positive remainder 1. So the form of the number will be LCM of 3, 4, 5 into k plus 1 into k plus 1. Suppose if I take k value 1. So n, I will get the lowest value. 12 5s are 60, 60 plus 1, 61. All are 3, 4 and 5. It is co-primes. LCM of co-primes, it is always their product. K value 1. If I put k value 2, 60 into 2, 120 plus 1, 121. N minimum will be 121. So every time there will be a deviation of 60. Next will be 181 and so on. So the form of this number will be 61 plus 60 into k. This was the last concept that we discussed. So this will be, k value will be 0 and so on, or here k value will be 1 and so on, 1 and so on. In both the cases, you will get k value 1, 60 plus 1, 61. K value 0, 60 into 0 plus 61. In both the cases, it is there. This was the last concept that we discussed. Yesterday, we solved in LCM session number 2, how to eliminate answer options based on the foundation of LCM, 61 plus 60. Now, if you see here, what I told you, you can optimize this question like this. Assume that this positive remainder is not there. What is the number that is perfectly divisible by 3, 4 and 5? The number that is perfectly divisible by 3, 4 and 5, it is LCM of 3, 4, 5 into k. The positive remainder will be 1. So added 1. Directly you can write this expression. This is for your understanding why it should be LCM of 3, 4 and 5. A number that is perfectly divisible by 3, 4 and 5. It is LCM of 3, 4, 5 into k. All the cases I am getting a positive remainder 1. All the cases I am getting a positive remainder 1. Yesterday one interesting concept that we discussed. Can k value be 0? If k value will be 0, n will be 1. What is the smallest natural number when divided by 3, 4 and 5 gives a remainder 1? What is the smallest number? Can it be 1 or 61? It cannot be 1, because for it to be 1, k value should be 0. K value 0. K is nothing but the quotient. K value 0 means n you are getting minimum value 1. 1 divided by 3. 1 cannot be divided by 3. If the numerator is less than denominator, it cannot be divided, so numerator will be written. 1 cannot be divided by 4. 1 cannot be divided by 5. In the question it is mentioned that what is the smallest natural number when divided by 3, 4 and 5. When you are dividing a number by 3, 4 and 5, numerator should be greater than the denominator. Then only the division will happen. If the numerator is less than the denominator, it will be as it is. It will be as it is. So n minimum will be 61, n minimum cannot be 1. I hope this idea is extremely clear to you. K value 0. If k value 0, n minimum will be 1. 1 divided by 3, 4 and 5. The number which you, if the question is divided by, then n minimum value should be greater than 3, 4 and 5. If the numerator is less than denominator, 3 is divided by 7. 3 cannot be divided by 7. So answer is 3. 19 divided by 7. Definitely. 19. 7 2s are 14. What will be the remainder? 5. What will be the remainder? 5. What will be the remainder? 5. I hope this idea it is clear. This is where we stopped our LCM session number 2. LCM